Hello everyone, this is Team SSL and we are presenting our SRE final presentation. Next slide. I am Shashank and I'll be going through the architecture of our site. So this is the component diagram for our site. Initially, we have created a primary instance which contains Nginx, which is a web server, which is used to perform operations like distributing traffic to the replicated backend sites. And it is also used as a load balancer. Then we have a GUnicorn, which is a web server's gateway interface, which is used to run Python web application. Then our VM instance also contain remote data collectors, FileBeat and MetricBeat. And the data collected from instance one will be transferred to the Elasticsearch, which is a data store. And these data can be accessed using the Kibana dashboard, which has visualization capabilities for data indexed in the Elasticsearch. Next slide. And then we will be performing the resilience testing on our site to observe how it performs in the real world scenario. And next, Nishna will continue.
Hello everyone, I'm going to demonstrate the to-do application and the monitoring. So this is our to-do application page. Here, I'm just going to enter the task with regards to our project and when we have completed those particular tasks. Let's just say presentation. And then the date. And then this was taking care of all our team members. And then we add this particular task. And here we can see the list of all completed tasks that we have added since the site has been deployed. That's all about our to-do application. And next is monitoring. From this graph, we can say that most of our response codes are in 200s. But over time, we had few errors. And these particular errors are significantly high on 21st of November. That's because we haven't had a particular page that has configured yet. So the application was not responding to the user, and hence we had errors. And from this graph, we can say that the memory usage of the main instance is greater than a replica instance with respect to the CPU usage or memory usage or the disk used. Here the inbound or outbound traffics are nothing but the direction of flow of data or the traffic. So the traffic passing from the network to the virtual machine is nothing but the inbound traffic. And the direction of traffic from the virtual machine to the network is nothing but the outbound. And we can, from the stats, we can say that the inbound traffic is significantly high than the outbound traffic. Sukanya is going to talk about data analysis part A.
Hi, I'm Sukanya. I'm going to talk about data analysis. So the data analysis was for 14 period of time before our site was like overloaded. So the total number of requests our site service was 11,827, and the data which our site sent in response was 2,747 KB. And here is the pie chart which shows response codes for all the requests, and 200 was the more one, and 200 was more. And next slide. Coming to the week, the day where our site was more popular was on 19th November, Thursday. The site received more number of requests on that day. And coming to the particular hour where our site was more busy was between 12 to 1 p.m. It received more number of requests during that time period. Next slide. Coming to the number of 500 errors, the site received 289 500 errors, and you can see the graph here. Next slide. Coming to the site's availability, it was a total request minus number of error requests by the total. You could see the site was 97% available. And coming to the number of total requests served by each instance, the main instance served 9,732 requests, and the secondary instance served 2,095 requests. Whether the site is doing a good job of load balancing or not, no, the site is not doing a good job, because the number of requests served by the main instance is more than that of this secondary instance. It should be almost similar for it to do a good job. So yeah, the site is not doing a good job of load balancing. Next slide. Coming to the memory utilization between both the instances, the instance one was able to handle the good amount of memory, but when the replica instance come into the picture, the replica instance took over it, and later after a few weeks, the main instance came back again, and that was the reason main instance was able to serve more requests than that of the replica one. And next slide. Uh, these were the top 5 client browsers, and Python requests were most of all of them. And yeah, next Leighton will continue about part B.
Hello, everyone. So now I'll be going over our analysis of the do work method and the latencies that we observed in our access logs from it. So the first thing that we did is plotted a histogram to show that the different frequency counts for these latencies. And then we attempted to try and match it to a known probability distribution. So we were able to rule out the uniform and the normal distribution because the histogram here doesn't really display any of the characteristics that we would expect from either of these distributions. And so that leaves us with the log normal distribution, and we do see some of the features of this one. In particular, we have a long right tail. The scale of this graph somewhat obscures it, but we have latencies as high as 1.2 seconds, which we don't see replicated on the left-hand side, which drops off at approximately 0.08. So this asymmetry in long right tail leads us to conclude that this is probably a log normal distribution with a center value of approximately 0.11. Next slide, please. To further confirm our analysis, the next step that we did was use SciPy to try and fit a probability density function for the log normal distribution. And so we can see in this histogram here that the distribution that we were able to fit to our data matches up fairly well. The curve lines up on the right-hand side, and the center value is at approximately the right point. The only issue that we might observe here is that the probability density function expects more values on the left-hand side than our system actually observed. One possible explanation for this is that how our backend is configured, or maybe due to the link speeds between components, we have an inherent floor latency that our site is capable of serving. And so we might not be able to serve requests any faster than 0.08 seconds. So we wouldn't see these lower values. Next slide, please. So to confirm our analysis even further, we take advantage of the fact that the log normal distribution means that the log of the values observed should produce a normal distribution. And so from here, we transform the data using that transformation shown on the slides on our original histogram to produce this new histogram, and then analyze whether this histogram looks more like a normal distribution. And so that we're pretty convinced that this is starting to look more normal. One thing that we can observe is that our left and right tails stretch off to the same values, now negative 7.5 and positive 7.5. This is in sharp contrast to our original distribution, which had very uneven tails. Additionally, we have a lot more symmetry around the center value. The two values slope off at closer rates. This isn't fully, they're not exactly the same. Our left-hand side looks a little bit sharper than our right-hand side. But if we think back to our previous slide and the fact that we're missing values that might be expected at the lower latencies in the log normal distribution due to site configuration, this would explain why our left-hand side is a little bit more severe, since we're missing these values otherwise, which might fill in the distribution a little bit. Next slide, please. So that concludes our presentation of the workings of our site. We hope that this information was insightful in the operation of our site, and thank you for listening.